Alright, so this is example 2 on linear dependence of functions. Example 2, show that the given functions are linearly dependent on the real line. Alright, so the three functions are f of x equal to 5, g of x equal to 2 minus 3x squared, and h of x is going to be 10 plus 15x squared. So plug it into the equation from the definition here. So it's going to be c1 times 5 plus c2 2 minus 3x squared plus c3 10 plus 15x squared equal to 0. And our goal is to find c1, c2, and c3 where not all of them are 0. Alright, so first we're going to distribute 2c2 minus 3x squared c2 plus 10c3 plus 15x squared c3 equal to 0. Now as you can see, we have the x squared terms here, and then just the constant terms here, and we're going to group them up and factor them out. It's going to be x squared negative 3c sub 2 plus 15c sub 3 plus 5c1 plus 2c sub 2 plus 10c sub 3, which is equal to 0. A note here, after we factor them out, on the right side it says it's equal to 0, and that basically means that is equal to 0x squared plus 0. So what we can do is we can set this here, x squared terms equal to 0, and the constant terms here also equal to 0. So we're going to get a system of equations, which is negative 3 c sub 2 plus 15 c sub 3 equal to 0, and 5 c sub 1 plus 2 c sub 2 plus 10 c sub 3 equal to 0 also. Alright, so now we have two equations with three unknowns, which means there is not a unique solution. There are infinitely many. So we're going to be able to choose one of the variables and pick what number based on our preference. So let's first work with this first equation. Alright, so negative 3c sub 2 plus 15c sub 3 equal to 0. Let's isolate c sub 2, which is going to be 15, negative 15 divided by negative 3, c sub 3, c sub 2 equals 5c sub 3. Alright, for the other equation, 5c sub 1 plus 2c sub 2 plus 10c sub 3 equal to 0. Let's isolate c1. So it's going to be 5c1 is equal to negative 2c2 minus 10c3 divided by 5 over c sub 1 is equal to 2c2 minus 10 c sub 3 divided by 5. Alright, what we're going to do now is we're going to plug this right here into this equation. So we're going to get c sub 1 is equal to negative 2, 5, c sub 3 minus 10 c sub 3 divided by 5, which is going to equal, this is going to be negative 10 c sub 3 minus 10 c sub 3, which is negative 20 c sub 3 divided by 5, which is equal to negative 4 c sub 3. Alright, this is where we get to pick our variable for c sub 3. I'm going to pick c sub 3 to be 1. Here's also another tip. So when solving out these problems, say we got c sub 2 to be 5 over 3 c sub 3. That's all. This is an example. This is not related to this problem. Say we just got this, and we're gonna pick a number for c sub 3. So what you want to do when it's like a fraction like this is you want to clear out the fraction with c sub 3 to make it easier for us. So it's going to be c sub 2, 5 over 3, and I would recommend that you choose c sub 3 to equal 3, right, to cancel this fraction out to make it a whole number. So in this case, c sub 2 is equal to 5 over 1, so c sub 3 is going to be equal to 1. Alright, so c sub 3 equals 1. Now let's plug 1 in here. C sub 2 is going to be 5, and I messed this up. This should be 1, c sub 1. Actually, no, this is right. This is c sub 3. So c sub 1 is going to equal, let's see, I'll plug in c sub 3 here. It's going to be negative 4. And that's it. You solved it. And if you want to check your answer, just plug it back in. So c sub 1 was negative 4, and then times 5, plus 5, 2 minus 3, x squared, plus 1, 10 plus 15x squared is equal to 0. Alright, so let's simplify this down. Negative 20 plus 10 minus 15x squared plus 10 plus 15x squared is equal to 0. As you can see, 15x squared cancel out, and the 10 plus 10 is 20, minus 20 is 0. 0 equals 0. And there we go. And remember, all these constant values, not all of them can be 0. Some of them could be 0, but not all of them.